Recording. So the first topic that we've done is polynomials, right? So polynomials, I think it's a kind of comfort spot for some persons, but it's not necessarily the way that you would strictly be able to just say, oh, something is a factor of, or could you find the remainder of? Sometimes it'll come like the question where they'll ask you to prove that P and Q are, or A and B are certain values. So I'll show you exactly what I mean by that, right? Now I'll give you all some time to do the question. However, in the interest of time, I may be going forward a bit too, like go forward a bit much. Unfortunately, if I pause for everyone, we won't get through the class. So that's why we're recording it, right? If you're not able to get through the question, it's fine, right? You'll get to look at the video after. So when I'm talking about a question where we need to solve for like P and Q or A and B or some two functions, right? It is something like this, right? So this is the 2022 paper. No, I'm now going to start screen sharing, right? This is the 2022 paper. So when the polynomial expression is divided by x plus 1 and x minus 2, the same remainder of 64 is obtained. Determine the value of C and D. So it's 4 marks, right? I'll give you all about 3 minutes. Obviously, I'll just take away a minute or so, right? Just in the interest of time. So try it. In the chat, you can let me know what answer you get for C and D, and we will see if it lines up, right? Right. Also, one other thing, I won't be doing any multiple choice with you all, right? Because of the so much repetition with the multiple choice, I'm leaving that up to you all. You all have to find a way to get those answers. Yeah. Um, I will, however, go through the multiple choice before your actual exam, but for the mocks, I need to leave you all to do some work. All right. So a question something like this, where you won't get it as straightforward because you realize this is 2022's paper. So this is the most recent paper. So Mr. Romeo and I will have to test you all on things that aren't as straightforward because now they'll be bringing questions like this. So what you have to do here is that, okay, so we have two scenarios here, x plus 1 and x minus 2, right? So we'll go with the first one. So what I do first, I will let this equal to a function. F of x is 2x cubed minus 3x squared minus cx plus d. So now I need to substitute two things into it. So x minus 2 is 0. So that means x is 2. right? Now, the reason why we do this first is because sometimes you get a bit confused as to what to substitute in, if it's the positive or the negative. I always do this. This is a foolproof way. So I'll get f of 2 is 2 by 2 cubed minus 3 by 2 squared minus c by 2 plus d. And I said that the remainder is 64. So I'll get 2 by 2 cubed is 16 minus 3 by 2 squared is 12 minus c by 2 is minus 2c plus d is 64. So 4 minus 2c plus d is 64 minus 2c plus d is 60. And then I'll do the next one. X plus 1 equals to 0. X is minus 1. So now I'll do f of minus 1 is 2 by minus 1 cubed minus 3 by minus 1 squared minus c by minus 1 plus d. And again, that's equal to 64. Now, some questions would give you a different remainder. Some questions would say a factor. Now, just note, factor has a remainder 0, right? So we'll get minus 2 minus 3 plus c plus d equal to 64 minus 5 plus c plus d, 64, c plus d, 69, right? So I now have two equations with two variables. You should remember this from math. If I have two equations with two variables, you automatically start to think simultaneous equations. So I'll line them up. Minus 2c plus d is 60, c plus d, 69. Now, in this case here, my two variables d have the same coefficient. So I could now just use the elimination technique. Now, whatever technique you use, by all means, right? I like the elimination because the coefficients are the same. So, same signs, we minus different signs, we add. So in this case, these are the same signs. So minus 2c minus c is minus 3c. d minus d is 0. 60 minus 69 is minus 9. c minus 9 over minus 3, which is 3. And then we will sub c equals 3 into equation, let's go equation 2. c plus d, 69, d, 69 minus 3, which is 66. And just to be safe, right, what I do, my students know this, I box off my answer. So you see how my working is not clear, like it's all over the place? It's going to happen because you're writing on the paper. To avoid like any kind of confusion, I box off my answer. So I'll put, okay, C is 3, D is 66. So the teacher who's marking would say, oh, right. Okay, so you got the right answer. Yeah, so I'll just repeat what I did. I took the two expressions they gave us, put it equal to 0, so I'll know what to substitute in. I'll get two equations with two variables. In that case, I arrange it as a simultaneous equation. So now that they're both simultaneous equations, I will solve for one variable using the elimination technique. You could use the substitution. You could even use matrices. I don't care, right? Whatever you use to get the answer, right? Some of your calculators can do it straight away. Don't, right? I need to see some working. We need to see some working, right? Yeah, you could double underline it as well. So you could do like this and like this. You don't need to box it up. You double underline, I would do it. Now, reality is, right, we will find your answer. but it sometimes just makes it easier if you double underline it, right? I know some students do that, or some students box it off, right? So I'll just give you a minute. You don't need to take it down because remember, I'll be uploading the video, right? I also want to do one that, I don't want to say you're all out of practice of, but it's just about remembering how to do it. Okay, so I'll do one other thing. Um, so ideally I want to end, that's a good question, right? How long am I going for? Ideally, I want to end at 9 for the latest, right? However, if we go a little after, I apologize. You can leave at any time. All right. I'll just upload the video. All right. So again, in the interest of time, you will just have to pause the video when I upload it and get it right. I apologize for that. Right. So another one I wanted to do, right, was find, or we could say given x minus 1 is a factor of, let's say, x cubed. I'm gonna get one that works out. Right, is x cubed minus 6x squared plus 11x minus 6. Find the remaining factors. All right, so this is another one where you actually have to use the long division. All right, so I'll give you all, I'll give you all 3 minutes, right? Usually this comes to about 4 marks. I'll give you all 3 minutes. See if you all could come up with the other two remaining factors. Yeah, so everything we've done, right? Everything we've done is coming. Right, so let's line it up, right? So we will go x cubed minus 6x squared plus 11x minus 6. Let's reset. Right, good. And then we'll put x minus 1. So just remember how to do it. We take this first term and put it into here. X into x cubed is x squared. Then we take this and multiply it by the whole term. X squared by x minus 1 is x cubed minus x squared. And we subtract both of them. Now, sometimes you just kind of mix up the signs, right? So what I recommend, just to be safe, put this in brackets. Yeah. That way I don't mix up the signs. X cubed from x cubed is 0. Minus 6x squared minus x squared is minus 5x squared. And then we repeat the process. Actually, we do one other thing. We bring this down. Plus 11x. Now we repeat the process. X into minus 5x squared. It's minus 5x. Minus 5x. Like this. Gives me minus 5x squared plus 5x, put it in brackets, minus 5x squared minus 5x squared is 0. 11x minus 5x is 6x. Bring this down. Minus 6. Then, we do one at a time. X into 6x plus 6. 6x minus 6. Both of these get 0. Now the goal is always remember, right, that if it's a factor, we should get the remainder as 0. If you didn't get the remainder as 0, you did something wrong, right? Now a lot of people stop here. This is not where you stop, right? You'll have x minus 1, and you'll have x squared minus 5x plus 6, right? A lot of people stop here, don't, all right? This could factorize, right? So we'll get x minus 1. And how do we factorize this? This becomes x squared minus 2x minus 3x plus 6, x minus 1, x into x minus 2 minus 3, x minus 2, x minus 1, x minus 2, x minus 3. Always convert them to what we call linear factors, right? So always convert them. Now, as you can see, it's a bit of a complicated process. If you stop up to here and you don't convert it, you usually lose a mark, right? However, I would say do the long division, and only if you have time, make a swing back. That's it, right? Always remember that, right? You're gonna have to get all 3 of them. Now, this is what we call a time-consuming question, right? This question takes time. Now, if you know in the exam, you're gonna get tired up, use this as your guide. If it's taking you more than 4 minutes, come back to it. Yeah. Right, and that's really it. All I need to know for the remainder and factor theorem, right? That's really it. There isn't anything much that I could bring that would say, you know, it's a bit out of the thing, right? So, right. So this one is, so some of you all may have gotten x minus 1, x plus 6. That is wrong. All right, and I'll show you why. So some of you all did x squared plus x minus 6x plus 6. So you get x into x plus 1 minus 6 into x plus 1. So you get x minus 6, x plus 1. That doesn't work. I'll tell you why. Right? Because these two numbers here are positive. Right? So we'll have x squared minus 5x plus 6. So if we did the AC method, this is 1 times 6, which is 6, and b, which is minus 5. I need two numbers. When multiplied gives you 6, and when added gives you minus 5. Now, in this case here, because this is positive, you need both of them to be the same sign. Yeah, so just be careful there, right? When in doubt, check your calculator. Yeah, just make sure, right? Right, so what I did to get from x cubed minus x squared to minus 5x squared, I minus it. X cubed minus x cubed is 0. So if you want, this is confusing you, put the 0 here. Minus 6x squared minus x squared becomes minus 6x squared plus x squared, which is minus 5x squared. Right? All right, so I'm going to do an AP question now. Right? I won't be looking at GPs, hint, hint. Right? So let's look at an AP question, right? So if T5 is equal to 20 and it doesn't matter. So that's a good question, Shane. If they ask for all the remaining factors, you can list all of them. It don't matter. Just for safety's sake, list all of them. So if T5 is 20 and T8 is 31, actually let's do 32 for an AP. Find S12. Right? Now remember, for an AP and GP, don't beat up, right? Don't fuss up, don't worry about it, the situation, right? You will be getting a formula sheet. So in that situation,
the test. I'm here. Sorry.
yes,
Hi,
Mr.
sir.
Otley,
Sorry, what we did so far?
polynomials.
Basic shit. I read it.
So in the exam itself, I'll be giving you all the formula sheet. And the formula sheet does give you the APs and GPs. So Tn is A plus n minus 1d. Sn is n over 2, 2a plus n minus 1d. Right? So the second page of your exam will be your formula sheet. So do business, right? This is T8, by the way. All right. So try it. See what you get.
How's your afternoon, sir?
It was fine. How was yours, Mr. Utley?
I had training today, actually, but I got demon dogs. I have a question. With regards to vectors and things, that's coming with like dot product and whatnot, right?
Yes.
Alright, safe, cool. And I heard paper ones are real hard.
I sent a set to
And
the groups. So you can use those to practice. Yeah?
You alright?
Yeah.
You sound deaf. You didn't even respond to me and things, so I thought you was ghosting me or something.
I probably was, but that's just for you.
Yeah, well, you want something from me just now. Anyways. Okay, sir. Thanks much.
Sir,
No problems. Yeah.
with regard to the formulas, what does A and like D mean?
A is the first term, D is the common difference, N is the number of terms.
Thank you.
So I'm coming back and I can't tell us I can be it.
Okay, I didn't need to know that, but
Otley,
sorry.
shut up.
Right.
Right. So that was an interesting, what, 2-3 minutes? Yeah. So when we look at this question here, right? Again, if you're weak at it, brush up on it. It's another simultaneous equation, right? Now, the key to doing this is always write what you know versus what you don't know. All right? Yes, so you would have to use simultaneous. So in this case here, always, try to get it. So T5 is A plus N minus 1 D. So we have N, A plus 5 minus 1 D, which is A plus 4D, and we say that is 20. Right? And then we have T8, A plus N minus 1 D, A plus 8 minus 1 D, A plus 7 D, which is 32. I have two equations, two variables. We should know what that is, right? We have two variables, two equations. So that becomes equation 1, equation 2. A plus 4D is 20, A plus 7D is 32. We can minus both of these because A is the same. So 40 minus 7D minus 3D, 20 minus 32 is minus 12. D is minus 12 over minus 3, which is 4. And we could sub D equals 4 into equation 1. So we'll get A plus 7 by 4 is 32. A is 32 minus 28 is 4. Now, again, a lot of people stop here, but you have to look and see what the question is asking for, right? The question asks you for S12. So that is where we find now S12, 10 over 2, 2A plus N minus 1 D. We substitute everything we have now. 12 over 2, 2 by 4, plus 12 minus 1 by 4, 6 into 8 plus 11 by 4 is 44. 6 by 52, which is 6 by 50, 300 plus 12, 312. Yeah. So I'll give you all one more like this. All right, so I'll give you all one more like this, but I won't be able to do it in class because I have another topic I want to go on to, right? So I'll just write it here for you all to try it. If T6 is 28 and T12 is Minus 4. Actually, hold on. Want it to be something that works out good. Minus 8 for an AP. Find S20. Find S20. So if you like this question and you wanted me to do, if you want to try it yourself, try another one, right? You could do one like this. You won't find this, in the past paper as much, right? So that's why I'll give you an extra one. Okay, so what's next on the agenda? Let's see here. So I'm looking at your paper now. So that is about, I would say so far, you should be able to get 15 marks so far. So your paper is out of 100. So that's 15 marks locked down. All right. Let's do the question everyone hates, right? Right. And the question everyone hates, and it's, I want to say it's difficult, but a lot of people get that whole shudder when they hear the word, right? Just gonna pull it up here. There we go. Let's go. Logs. Yep. Let's see how y'all do it. All right. Something like this. Now, this is a very common log question where they give you it and you have to convert it to a quadratic and then you will do it. All right. So let's see. All right, now man, everybody talking big. Let me see what answers y'all get. What answers y'all get for this logs. So I feel like there was a line there, James, that they need to be crossed. So let's just get back to the logs, right? Let's just get back to the logs and that's a good request, Joe, but I feel I'll do that for the actual exam and not for mocks. I feel there's a reason why I won't do that one for
Yeah,
mocks,
right.
right? Yeah, cool. I think like I'll pay particular attention to this one, right? Right, so if you remember clearly, this was one of the questions that came for was it in the term? I think it was in one, I think it was last year in the term. Is that one or form for term 3? Either one, right? So yeah, form 4 term 3. So what you do with this one, right? Right, so let's just, I'll continue class like this. Let's just say all the questions that we're looking at. Now I would pay particular attention to. All right, so this becomes log 3. When we add logs, we multiply x plus 2, x minus 1 is equal to log 3, 6x minus 8. So yeah, just trying to, right, cool. So now if we have log A equals log B, then A equals B. So we could do that. We're not canceling out. Like, I don't like to use word canceling out with logs, but we just, that's essentially what we're doing, right? That's a very good question. No, you cannot have log of 0. You can never have log of a number less than or equal to 0. So now we'll have x plus 2 by x minus 1 is equal to 6x minus 8, x squared. So I'm just going to be working a bit faster, right? X squared plus x minus 2 is equal to 6x minus 8. X squared carried over minus 5x plus 6 equal to 0. So we would get x minus 3, x minus 2 equals to 0. So we'll get x equals 3, x equals 2. Right, so just remember, we cannot have log of a where a is less than or equal to 0. Right, that's the only hint I'm giving you. So if we get, so like, I'll just use an example here. Let's say I got x equals 1, and x equals 1 would not be a solution. Right? And the only reason why is because if I put 1 minus 1 here, I'd get log of 0. Yeah. So right, so how do I get rid of the 6x minus 8? When I carry it over, right? This becomes minus 6. When I carry this over, it becomes plus 8. Right? Now don't be too hard on Mr. Batch, right? This is always a confusing one, right? It's the same quadratic as before, right? It's always one that confuses people with the minus 3 minus 2 or plus 1 minus 6. So just be careful with that, right? It's good that it came up because yeah, it's very easy to mix up. All right. All right. So let's look at another one. Right, so again, so that should lock down some marks there. All right, let's go back to my OneNote. I want you to prove √5 plus 3 over √5 minus 3 is equal to because I know all I can use all the calculators, you know. Actually, let me just say reduce. √5 plus 3 over √5 minus 3. All right. I just want to see how you all will do it. Right now, when you reduce something, you try to get rid of the surd in the denominator. They like surds in the numerator is fine. You see, when it goes on the denominator, that's when it does get very very iffy. I don't like it. Right. So in this case here, to get rid of a surd, you multiply by the conjugate. What is the conjugate? The conjugate is the term with the opposite sign. So for example, if this is √5 minus 3, it becomes √5 plus 3, √5 plus 3. So we would get √5 plus 3, √5 plus 3 over √5 minus 3, √5 plus 3. Now, why do we do the conjugate? It's simply because a plus b, remember, a plus b by a minus b, a squared minus b squared. So we'll expand this as usual, √5, 5 plus 3, plus 3 over √5 squared minus 3 squared. √5 by √5 is 5. 3 √5 over 5 minus 9. So we get 14 plus 6 √3 over minus 4. Now, you could reduce this. Personally, I wouldn't take the risk to reduce it. right? I would leave it like that, although the question says reduce. I can leave that because next thing you know, I put some wrong, right? I would, but to reduce it properly, divide everything by -2. -2 into 14 is -7. -6 into -2 is -3√3. -4 into -2 is 2. Right? Now, if you have the Casio
Says
calculator,
root 5.
what's that?
Root 5.
0. All right, thanks. Yeah, √5. 5, √5. Yeah, right?
So
I just divided by -2 to because that's the easy way of reducing it. Yeah, question? Who had the question? Who's asking?
After you rationalize, can you explain what you did like when you put them together?
This here, right? This?
Yeah, from the
Right. So what I did, I expanded. So I take this √5 and multiply it by the bracket. I take the +3, multiply it by the bracket. And on the underneath here, because I have reformed a minus b by a plus b, it's the difference of 2 squares. So this becomes a squared. So in this case, a is √5 and b squared, b is 3. And I just reduce it down. Right? We do not multiply by the square of the, yeah. We do not multiply by the square of the denominator because we want to get rid of the surd in the denominator, right? We try to get rid of the surd in the numerator. We get rid of the surd in the denominator. If we just square it, we'll end up with a surd. If you know you did it, if you know you're getting a surd in the denominator, you know you did it wrong. The goal is to always get a surd in the numerator. A surd in the numerator, but a whole number in the denominator. So in this case, you see how I got -4. Do that, right? I could have divided by 2 or -2. It didn't matter, right? I just chose -2 because, you know, I just felt it, right? I felt that was the easier one to do. All right. Let's see what else. We have to do circles now. Yes, circles. I will skip over the quadratics because y'all did that for math already. All right. What I would just say, learn your alpha plus beta, alpha beta, 1 over alpha plus 1 over beta, 1 over alpha beta, alpha squared plus beta squared, 1 over alpha squared plus 1 over beta squared. Learn these, right? Learn what they are, learn the formula, and learn how to make the quadratic. Okay, learn it. Right? When they ask for minimum value, they're asking for the y value. If they ask for the minimum value of x, they ask for the x value. All right. Let's do a circle question now. Now, let's see here. I'll do a circle question, then trigs, and then a bit of differentiation and integration. All right, and we'll round off with stats. Okay, so I know I'm being a bit ambitious tonight, but I will try my best. Okay. The differentiation I'll kind of breeze over, right? Because yeah, differentiation you'll kind of have on lock, right? Let's do find the normal to the circle x minus 3 squared plus y minus 2 squared is 25 at the point -1 make sure it work out -1 5. Yeah, so I'll post the Zoom link. I will try to post it tonight actually. As soon as it finish records, as soon as it finish converts, I will put it to upload, right? So by latest you should get tomorrow morning. All right, so find the normal to the circle. See if you all can remember how to do this. Right, so the difference between normal and tangent is the gradient, right? So the tangent would have a tangent gradient, the normal would have a normal gradient. If you want to see it as a diagram, right? If I have the circle like this, that's a horrible circle, and this is the point here, a line like this, let's say this is the radius, this would be the tangent, and a line going straight up would be the normal, all right?
See how much marks for that question?
That one would be like about 4 to 5 marks. It'll most likely combine it. So there'll be like find the equation of the circle and then find the equation of the normal or tangent. Or they would just get the equation straight until they find the equation of the normal or tangent. It's usually like 4 marks. Yes, so you try to use the coordinates of the center to approach it. All right. So how do we approach a question like this? So first thing we do, identify the center, which is 3, 2. Then we have the point, -1, 5. What could we have 2 points. What could we find? We could find the gradient. M is y2 minus y1, x2 minus x1. So we'll go 5 minus 2 over -1 minus 3. So we get 3 over -4. M of the normal is just the same M. Yeah, you don't need a business there, don't need to beat up. So now we have the gradient of the normal, which is -3/4. And we have the point on the normal, which is -1, 5. So now we could use y minus y1 equal to m into x minus x1. Don't forget this formula. This formula would save your life, right? So y minus 5 minus 3/4 x minus -1. Y minus 5 minus 3/4 x plus 1. Y minus 5 minus 3/4 x minus 3/4. Y minus 3/4 x plus 4 1/4. So when they ask for the normal to the circle, they're asking for this line here. This line that they have there. All right. All right, so trigs, right? Going on to trigs next. Yes, correct, right? So yes, you could also do that. So 2 things. 1, right? The normal is not the radius, it's the line outside. And Joey, you make up a very good point. You don't need to use y minus y1 equal to m into x minus x1. If you have y, let's not use the highlighter, y equals mx plus c, and you do y minus 3/4 x plus c, and you solve for c and then put it in the equation, that is also fine, right? That I'll accept that. Full marks, right? So don't
So
worry.
that equation is not for the tangent too? I thought that was for the tangent.
Right. So the tangent, so very good question. What if they ask for the tangent? What would you do in the tangent in this case? What do you do? The m of tangent would be -1/m. So in this case, it would be so on, which would be 4/3. And you do the same process just with the 4/3 gradient. You understand now? Yeah.
Say that again?
So what you do, if they ask for the tangent, use the tangent gradient, which is -1/m. And you do the same process, right? If they ask for the normal, you use the normal gradient. It's the same process you're doing, it's just the gradient that changes. So hopefully that makes sense. All right. So right, so take a look out for this one. All right, now traits. Yes, we all love traits, right? So every trig function has two solutions based on the quadrants. Right? So you can have this here, A all S sine T tan C cos. So what does this mean? All is positive, sine is positive, tan is positive, cos is positive, right? And this runs between 0 to 90, 90 to 180, 180 to 270, 270 to 360. And how do we work it out? Theta is theta r, theta 180 minus theta r, theta 180 plus theta r, theta 360 minus theta r. Right, where theta r is the positive result. Right? All school teachers curse, right? That's how I remember it, right? What we did in class will remain what we did in class. Class is being recorded. So we will leave that as is, right? You all know whatever way you use to remember it, whatever acronym you use, keep it to yourself. What we did in class stays in class, all right? The one that we use officially is all school teachers curse, right? So what is the method, right? So the steps. 1, identify what quadrants they belong to. 2, make the result positive and solve for theta r. 3, apply suitable formulae based on quadrants. So what do I mean by that? All right. So all means, right, so two things, right? So pi is if we're dealing with radians, right? There's a reason I'm not going through radians. Right. Secondly, right, all means that no matter what the function is, it will all be positive. So sine, cos, and tan is positive in the first quadrant. So, right, this has first quadrant, second quadrant, third quadrant, fourth quadrant, right? So let's do the example here. So example, sine theta is a half. Y'all tell me in the chat, what are the two values of theta? All right. See if you can remember. Right. So the first thing we do. So we draw our little thing here, ASTC. You look and see where sine is positive. Sine is positive here and here. So sine is positive in first. So I usually write it like this: first and second quadrant. Next, convert the result of positive and solve for theta r. Now in this case, it's already positive. So sine of theta r is a half. Theta r, sine inverse of a half, which is 30 degrees. Right? Now again, we're working in degrees for this class because, you know, yeah, right? We won't worry about radians, right? So don't fuss up too much for it, right? If you know how to do radians, great, right? For the exam, yeah, right? I would keep a calculator, look and see what rate you're asking for. If they ask for degrees, make sure you calculate in degrees, right? If they ask for radians, make sure you calculate in radians and so on. So now, theta being in the first and the second quadrant, what is the formula for the first quadrant? Just theta r. And what is the formula for the second quadrant? 180 minus theta r. So you get 30, 180 minus 30. So you get 30 and 150. So very good, those who got it, right? So that the second rule don't make sense in this thing, right? Some of you always saying, well, that second rule, how to do with it? Let's look at another one. 2 cos theta is minus a half for me. Tell me what answer you get. Right, sorry about that, guys. Right, so it is, if you did it correctly, you get, let's look at it now, right? So cos is negative in the second and the fourth quadrant. So it will be second and fourth, right? So cos of theta r, when I say make it positive, make the result positive, you make this a half, right? Theta r is cos inverse of a half, which is 60 degrees. So that is where, oh yeah, sorry, third. What nonsense I say in there. Second and third. All right, very good, thanks. All right. So theta being in the second and the third quadrant would have the formula 180 minus theta r and 180 plus theta r, which is 180 minus 60, 180 plus 60 becomes 120 degrees, 240 degrees. Yeah, so this is where the second result comes into play, right? So if you have something like that, the change for theta r, you always work it out as the positive value. Yeah, never forget that step. So that way you could apply the formula correctly. All right, so hopefully that clears it up, right? Just check your the quadrants you used, all right? So just be careful. So that's a good question. For the first quadrant, it is always positive. All is positive. So it only counts towards a positive value. So the first quadrant is positive. So anytime you see negative, you know that the first quadrant does not count. It's always the other quadrants you're looking at, right? And that makes sense because if you was to, so how do you get that, right? I'm just showing you here. If I was to draw a graph, right? And I go 1, 2, 3, 4, 1, 2, 3, 4. In this first quadrant here, this will always be positive, right? So that's how you look at it. Yeah, that's pretty much how you look at it. The other quadrants, just learn it off, right? You don't need to learn the theory behind it. Maybe after mocks, if you're curious about the theory of why they have that value, I'll show you in our own time. All right, okay, and that's really it with regards to trigs. All right, so the proofs, all right, I'll put it this way, right? The formula sheets have these formulas here: sine a plus or minus b, cos a plus or minus b, tan a plus or minus b. Use them. Use it. Right? Yes, correct, Alvin, right? So the trig graphs would show where they're positive and negative and how they oscillate and whatnot. But for the proofs, right, that's all I'm going to say. Proofs aren't as much marks as they used to be. Proofs are probably about 3 marks at most in the exam these days. So I personally think if that's a headache for you, that 3 marks not worth dying for. Put that 3 marks in your stats or in your differentiation integration, and when the proofs come, just try to reason it out, right? Let's move on, right? These 3 formulas here, sine a plus b, cos a plus b, tan a plus b, and plus or minus, right? They will be given in the formula sheet, all right? Yeah, so right now CXC has realized that, and especially you see how what happened. Now I'll explain it. Okay, just take a minute. Why the proofs no longer occupy so much marks they took these three things off. There are three others. So you know sine, cos, and tan. There are three others: cosec, sec, and cot, right? Those were three other formulae that you had to learn back in the day, right? Back when I was a wee lad, I had to learn sec, cosec, and cot, and that is where you could bring a lot more proofs. But because you don't have to learn it anymore, because now I'm an adult and you all are the wee lads, you all don't have to learn these. So that is where your proofs are no longer as heavy hitting as they used to be. All right. Okay, so let's move on. Yes, cosec is the same as CSC. Right. Vectors too easy to go through. Vectors, they're giving you the formula for everything, right? If all they get the vectors question wrong, I tripping off, right? Because they're giving you the dot product, they're giving you the angle formula, and they're giving you the modulus, right? So if all I get that vector question wrong, I tripping off, right? Let's do quick one here, right? Find the stationary point and their nature, or I'd say, and its nature for y equals x squared plus 3x plus 5. Right, and when you see nature and stationary point, use differentiation. I don't want to C minus HK, right? If I C minus HK, you're in the wrong section. Right, so to find stationary points, right, it's dy dx equal to 0. So dy dx is 2x plus 3 equal to 0. 2x is minus 3, x is minus 3 over 2. Now a point has a x and y value. So y in this case, 2 minus 3 over 2 squared plus 3 over 2 plus 5. Another mistake people make is subbing it back into dy dx. You'll automatically get 0 as your answer. Don't plug it into y because a point has a x and y point, right? So we'll have, this is what? 2 by 9 over 4, 9 over 2 minus 9 over 2 plus 5, which is 5. So our stationary point is minus 3 over 2, 5. Where I get the 2 from? X squared plus 3x plus, oh, yeah, yeah, yeah. Don't know why. Right, so this is, oh, I know why. I was doing d2 over dx already. 9 over 4 minus 9 over 2 plus 5, which is 9 over 4 minus 9 over 4 plus 5. Yeah, it's 9 over 4. Nah, they're correct. Right? So this becomes everything over 4, 9 minus 18 plus 20, which is 11 over 4. Yeah, is that what y'all got instead? And then for the stationary, for the nature, we do d2y over dx squared, which is in this case 2. And since it is greater than 0, it is a min point. Right, so in this case here, we then need to sub in x, right? If you get the stationary points, you sub in x if it's greater than 0. So just remember, if d2y over dx squared greater than 0, it is a min point. If d2y over dx squared less than 0, it is a max point. Right? Now again, stationary value is the value where it's either a peak or a trough, right? So it's either here or here. Yeah, so that's what a stationary point is. Okay, no need to worry about what it is. But to be honest, this year group as a whole handles differentiation real good, right? So y'all, I have nothing to worry about with differentiation really. I'm going to go into kinematics, right? So, right, kinematics and then statistics, all right? The integration, I could trust you all to revise that, right? So for integration, just remember, right? I'm only doing that because it's 9 already. I want to finish. I want to wrap up by 9:15. All right. I apologize for that, but obvious reason is obvious, right? Integration, we have area, equation align, bounded integration, right? So that is like with B and E, regular. Yeah, about it really. And you all can handle that, right? And well, obviously kinematics, which we're doing now. All right. So with kinematics, you let S be displacement. VB velocity and AB acceleration, right? So we use calculus to solve for this. All right, now just remember, it's always with respect to t. Now, I always do this for my students, right? So don't feel like, this is something that, is out of the ordinary. I'll always do this. Even after mock, so for the 2-month vacation, 2-week vacation and so on, I'll be having classes like this as well. And it's always welcome for all students of Fatima, right? So it doesn't matter what class you're in. All students of Fatima are welcomed. And so after mock exams, when things are a little more relaxed, where we could do these classes and not have to rush, right? We'll be looking at past papers, multiple choice, and so on, right? That way we'll be prepared for the exam. No, unless you're a girl from Fatima, which, okay, I don't know, maybe it's 2023, right? But yeah, I usually just keep it for Fatima, right? Okay, so
Sir,
yeah.
on the integration, then you have the area and equation of the line. What does that mean?
So those are the topics on the integration that you should be looking out for. So if you're asking for like area under a curve, if they're asking for the equation of a line, bounded, so like if you have limits, regular, and then you have kinematics. Those are the topics for integration you should know.
Okay, thank you.
Yeah. Right. So just know to get from one to the other. So if I have S for displacement, right? Velocity is ds dt. So I differentiate displacement with respect to time. And A is dv dt. And we could go in the opposite direction as well. If I have A is acceleration, then velocity is the integral of acceleration with respect to t. And by displacement is the integral of velocity with respect to t. Right? Now there are terms we need to know, right? Terms. At rest means S is 0. Sorry, at rest means V is 0. Right? Starts means T is 0. I wanna feel like I put the other terms as well, If I say starts at 0, right? Yeah, that's it really. I think those are really ones that you all have to do. Rates of change. I'm gonna ask some good questions, but yeah. Let's just say there's a reason we didn't go through rates of change. I'll leave it like that. You all didn't hear that from me. I didn't say nothing about rates of change. Right. But yeah, there's a reason why we didn't put any emphasis on rates of change. So terms at rest, V is 0, starts, T is 0. All right. So let's do an equation. Let's do a question, right? How is that? How is that? Right, cool. If the velocity equation V equals t squared plus 2t plus 1, find 1 time when Let's change this to minus 2t. Minus 2t. Time when v equals 0. 2. Displacement at t equals 5. And 3. Acceleration equation given at t equals 4, a equals 7. Try that. If you could do this question, you could do anything with respect to kinematics. All right, try this. All right, let me know your answers in the chat as well. All right, I'm trying to send it privately as well. I want to give everyone a chance to No, I want the actual displacement at t equals 5. So you'll find the equation and then you will put t equals 5. Right. So time when b equals 0. So I'll put, so at b equals 0, 0, is t squared minus 2t plus 1. So 0. T squared minus t plus 1. 0. T into t minus 1, t minus 1. 0 is t minus 1, t minus 1. So t is 1. Right, you can put 1 second. Right, now I just write out the word second because as my students know, my S looks like a 5. Right, so I just be safe, right? Displacement at t equals 5. So S is equal to dv dt, which is 2t minus 2. And at t equals 5, this is 2 by 5 minus 2, which is 8. Notice I didn't put 8 meters or whatnot. It's simply because the equation didn't specify, right? Usually you'd put like 8 meters or something like that, right? Acceleration, so 1, 2, 3. Acceleration equation given at t equals 4, a equals 7. So a is the integral of v, integral of t squared minus 2t plus 1 dt. T cubed over 3 minus 2t squared over 2 plus t plus c. But notice I'm here, right? That c not supposed to be there. So that is why they gave us this condition. Oh, I did it in reverse, didn't I? Oh, I did it in reverse.
Sir, I know gonna say because
Yeah.
the acceleration would be the derivative of the velocity, and then you'd integrate for the displacement.
Yeah, right. Okay. That's right. Yeah. Sorry about that, guys. Right, so let's just change the questions. So this is at t equals 5. Let's say if at t equals 5, s equals 12. All right, sorry about that. Right, so s is the integral of v dt, which is t cubed over 3 minus 2t squared over 2 plus t plus c. Good, y'all. Right, so I see everyone here. Tell me the chat. Thank you. Right. So when you have something like this with the plus c, you need a condition. This condition is given, right? But if it's not given, look for keywords. Look for the words at rest, starts, etc. That way, yeah, sorry about that, right? Yeah. So this would be, so what they say at, if s is 12 and t is 5, s is 12 and t is 5. 12 is 5 cubed over 3 minus 2 by 5 squared over 2 plus 5 plus c. 12 is 125 over 3 minus 25 plus 5 plus c. So 12 is 125 minus 20, 65 over 3 plus c. So c is 12 minus 65 over 3. That is 35 minus 65 minus 36. So that's 59, 29 minus 29 over 3. So s is t cubed over 3 minus t squared plus t minus 29 over 3. Yeah, again, sorry about that, guys. Just, yeah, class getting a bit long, right? 3, acceleration is dv dt, which is 2t minus 2, and at t equals 4, 2 by 4 minus 2, 6 meters per second squared. All right. So once y'all could do this, nothing they bring in, because I realized they stopped bringing the graphs in since kinematics get put into the differentiation and integration questions, they stop bringing the graph because you know they had to fit it in that 15-mark question. All right. Right, so just a couple other things I have to finish up here, right, with statistics, all right? So how do I get T3 over 3? Right, so good question. Yeah, add 1 to the power and divide by the new power. That's when you integrate. So T to the 2 plus 1 is 3 over 3, right? So it becomes T cubed over 3. Yeah. So, yeah, right? So that's fine. All right, so set now. Right, so with statistics. All right, so I need to go through standard deviation and variance with you all after the mock exam. Let that be a hint as it may, right? I am not going over standard deviation and variance until after the mock exam. That would mean that you won't really need to know it for the mock exam. Right, so yeah, we'll go through it after, right? Don't beat up too much about the standard deviation and variance because I need to go through that a bit more. All right. No, the C is just the value put at the end. All right, so you just put that at the end. Statistics, mean summation of x over n, all values over number of values. Median is the n plus 1 over 2 term. This is the position, right? Just remember that is the position, right? Q1, which is the lower quartile, is the n plus 1 over 4th term or position. Q3 is the upper quartile, which is the 3 by n plus 1 over 4th term. Mode is the one that occurs the most. Range, highest minus lowest. Let's do the diagrams. Stem and leaf. Right, so it looks something like this: stem, leaf. Right, you'll have like 0, 4, 6, 8, 9, and a key. 1/4 is 14. No commas between numbers, and it's in ascending order. That's the box and whiskers, right? And box and whiskers. The extra T. Because when you integrate 1, you get T. Integral of T squared is T cubed over 3. Integral of 2T is 2T squared over 2. Integral of 1 is T. Right? Fox and Whiskers, it looks something like this. Right, you'll have the highest value here. You'll have the lowest value here. Have Q1 here, Q2 here, Q3. Now, I should also note this is also the median, and it is drawn to some scale. Yeah. So like make sure you put like 1, 2, 3, 4, 5, whatever it is, right? Yeah, that's about it, really. Right? Yeah, I'm gonna do that now. One quick review of probability, right? Because I have to go in like 3 minutes. Yeah, I can finish that in 3 minutes. Probability, right? Yeah, the asserts will come, indices not so much, right? Probability, the universal equation, probability of A union B is the probability of A plus the probability of B minus the probability of A intersect B. It goes on the edge, right? No, it's not on the same OneNote. I'll probably send you only OneNote after. Right. This scale here goes on the bottom of the Fox and Whiskers, right? So you kind of put it there. Right. Probability A union B is A plus B minus A intersect B. Probability of A given B is the probability of A intersect B over the probability of B. We try to let these two letters be the same. Right? Two events are independent if the probability of A times the probability of B is the probability of A intersect B. Two events are mutually exclusive if the probability of A intersect B is 0 and for a tree diagram, and means multiply or means add. All right. Okay, guys. So that's it for tonight's class, right? I apologize if the last set there was a bit rushed, right? If y'all are doing questions, right, send me them. I will try my best to take a look at them. Right. Yeah, I'm gonna see if I could leave this to convert, and then I will upload the recording. People from my class, if y'all could forward it to those in Miss Romeo's class, right? I know some of y'all don't have my number, y'all got the link from them. I will send you all the video link as well. All right, guys.
How we good in it?
How what?
How we gonna send it to good in?
I'll email it to him. Yeah.
I want to group chat with some of them. Oh gosh.
Good in here. Good in here.
Yeah,
Yeah,
I
I'll
sent
get
it to
it.
him.
cool. Right? Yeah. Yeah, so I will do that. The mocks is not as bad, right? If you realize the mocks this for the majority of your exams were okay, they were decent, right? They're not necessarily easy, but I'll say they're less difficult than you anticipated. All right. All right, guys. So that is it from me, right? Thank you all for coming, for joining the class, right? Hopefully it's beneficial. Any questions you all ask me, right? Tomorrow I'll have my WhatsApp open, right? Just hit me a message, all right? I will see you all Wednesday for the test, all right? Just take it easy. Don't over cram, don't over study, right? You know some stuff. If they don't try and be a hero, say like you struggle with Radians, don't try to learn Radians tomorrow night, right? Accept that Radians as a bit of a lost cause, and you know you'll learn it for the actual exam. Try to focus on the things you're strong at. All right. All right,
That's
guys.
it, thanks a lot.
Yeah.
Thank you, sir.
All right, guys. I'll take
Thanks,
care.
sir.
Thank you, sir.
All right, sir.
Yes, sir.
Thanks, sir.